Okay guys, today what I want to show you is the difference between a prime number, a composite number, and the one exception, and then how to determine if a number is prime or composite. So let's begin with the definitions. A prime number means that this number has only two factors. Now remember, factors are the numbers we multiply together to get a product. So if there are only two numbers, one times the number itself, then that number is called a prime number. A composite number has three or more factors. Now when we're determining if a number is composite, the only thing we really have to do is prove that it has a factor in addition to one in the number itself, which we'll look at in a minute. As long as we can find a third factor, then at that point we can say it's a composite number. Now there's one exception, and that's the number 1. 1 only has one factor. A doubles factor we don't count twice, so 1 times 1 is the only way to get 1 using multiplication. So we don't have a name for it, and because we don't have a name for it, I gave it a name. I refer to it as Voldemort, because in Harry Potter he's referred to as he who shall not be named, and since 1 really doesn't have a name, it's not prime, it's not composite, we named it Voldemort, or I did anyway. Okay, now let's take a look at some examples of prime and composite numbers. These are 3 numbers that I went ahead and put up here so that you could see what I'm talking about more visually. 91. 91 is prime. I already know that, and I'll show you how to figure that out. When I say only 2 factors, 1 in the number itself, we have 1 times 91. There are no other factor pairs that we can use to multiply together to get 91. So we call that prime. Now, a composite number has at least 3. But what I wanted to talk to you about was the doubles fact. The number 9 actually only has 3 factors, because the other pair that we would have would be 3 times 3. And what that really means is the factors of 9 are 1, 3, and 9. We don't count that twice. We don't say it has 4 factors. Now we would say it has 2 pair of factors or 3 individual factors. And because we have 3, it's composite. Now the number 20, we start with 1 and 20. Now I picked that because a lot of you guys are going to be very comfortable with this number. You're going to know things like 2 times 10 and 4 times 5 all give us 20. But when we're deciding just whether it is prime or composite, then we only need to find that third factor. And because we found 3, then we can call it composite. It's not necessary to complete the whole set of factors because it doesn't make it more composite. Composite is composite. As long as it has 3 factors or more, we call it composite. Now again, to see this was the doubles fact, similar to the number 9. 1 times 1 gives us 1. Now I'm not going to put the multiplication symbol there. That means that we have this factor, but we don't count this as a second factor because it's the exact same number. So again, the number 1 only has 1 factor. It's not prime because you have to have exactly 2 factors. It's not composite because composite numbers have 3 or more factors. It only has 1. So again, I named it Voldemort because I think that's an easier way to remember it. There's one Voldemort. He doesn't have a name, and that's an important concept to remember. That's one that you'll see over and over. Now, couple important concepts when looking for a composite or prime number. 1, don't look for prime. Okay, that's going to be very difficult for you to do. Instead, prove that the number is not composite by using these factor finders. Most of the time you'll see these referred to as divisibility rules. They can be used that way as well, but that's not a phrase that I found productive for students. So we're going to just call them factor finders. The way they work, and I'll show you an example in a minute, is 2 is a factor for a number if there's an even digit in the ones place. Now the funny thing on all of these is the only exception to even numbers being composite is the number 2. That's the only even number that's prime. 5 is a factor for a number if there is a 0 or a 5 in the ones place, and again, the only exception to that is the number 5 itself. 5 itself is prime. Now 3 is a little different. You can't just look at the number, you actually have to take an additional step. The sum of the digits, meaning we add the digits of the number together. And if the sum of the digits is a multiple of 3, then 3 is a factor. Now for prime and composite, if any one of these 3 is a yes, the number is composite. If this is an O, this is an O, and this is an O, all 3, sort of thinking baseball, 3 strikes, you're out. And then you're called a prime number. That's when we proved that it's not composite, so we call it prime. So let's do a few examples. We used 2 as our first one. 2, we looked for an even number in the ones place. On the number 45, I would look for a 2, 4, 6, 8, or 0. I don't have that, so this doesn't help me. For 5, I look for a 0 or a 5 in the ones place. I have a 5 in the ones place, so this is a yes. At that point, I can stop because it has 1 times 45, and then it also has 5 times something else, which we don't have to figure out. We found a third factor. So 45 is composite. Now, for additional practice, I am going to go ahead and do this one. The sum of the digits means this. 4 plus 5, all the digits in your number. It can be used with longer numbers, however, we only go up to 99 in 4th grade. So 4 plus 5 equals 9. Now we're looking at this 9. That is a multiple of 3, counted by 3s. 3, 6, 9. So another factor is 3. I didn't have to do that, but I did want you to see this. Now, on this number, 28, I have an even digit in my ones place. That means that it's composite. I just proved it right there. Again, all even numbers are composite except the number 2, because 1 times 2 gives me 2. That's it. So it's an even number that's prime. It's also something you'll see over and over. Let's go ahead and do these two. There's not a 0 or a 5 in the ones place, so that is not a factor. 2 plus 8 equals 10. 10 is not a multiple of 3. However, because one of these proves that this is a factor, I now know I have 3 factors. It's composite. 51. Let's look at this. 1 in the ones place is not an even number. Sorry, you may hear the walkie-talkie going on behind me. 1 is an odd number, so 2 is not a factor. I do not have a 0 or a 5 in the ones place. Strike 2. 5 plus 1 equals 6. That is a multiple of 3. 3, 6. So that means that 3 is a factor. I do not have to go in and find the 17. My factors are 1 and 51, and I have the number 3 as a factor. That third factor proves that I have a composite number. Let's look at 19. The ones place, I always begin with these because those two you can just look at. It's an odd digit, so no. It's not a 0 or a 5, no. 1 plus 9 equals 10. 10 is not a multiple of 3. That's 3 strikes. Once I get to that third strike, and I'm going to remove this, that's when I say that 19 is prime. I just proved that it's not composite, so now I can say that it's a prime number. Let's look at 47. 7 is not even. Obviously, it's not a 0 or a 5. And 4 plus 7 is 11. That sum of the digits is not a multiple of 3. So this one also got its third strike. This is a prime number. I have one more number here, 39. 9. Not even. Not a 0 or a 5. 3 plus 9 equals 12. 12 is a multiple of 3. 3, 6, 9, 12. Remember, multiples are skip counting. So here we get a check. So that's composite. It's that simple. That's all that you have to do. And when you have a series of numbers, which is usually how this is presented, you simply go through these steps each time. Now, I want you to try a few. I've got this set up with 4 numbers. Remember, you look for an even digit, a 0. Here, let's go ahead and put this. A 0, 2, 4, 6, or 8 in the ones place. Here, a 0 or a 5 in the ones place. And here, see if I can write this sideways. We add the digits, and we look for a multiple of 3. Now, the exceptions to those are 2, 3, and 5. Each of these is the only multiple of that number that's prime. You only need one check. If you get a check, then it's composite. And other than that, I think you're very ready to do this. So good luck.